Alright, this is lesson 8.7, which is the very last lesson in Unit 8, where we're going to solve problems involving the change of dimensions, which means problems where like we go from one thing, we change the dimensions, and we ask ourselves how things change. So here's an example of this. You multiply the dimensions of a cube by 4. What happens to the surface area? Volume. So this feels really broad. You multiply the dimensions of a cube by 4. You might ask yourself, what cube? I don't see a cube, right? And that's where we're going to actually end up experimenting and drawing your own. Okay, draw your own. Okay, so if it doesn't say what cube, make your own up. So this is our original cube. I don't know about you, but I like picking really easy dimensions. So let's say that our original cube has side lengths of 1. That's pretty easy, right? Now let's go back and reread. You multiply the dimensions of this cube by 4. So we're going to multiply the dimensions by 4. So what are the dimensions of our new cube? It was 1. Multiplied by 4, so now it's 4. It was 1, and it becomes 4. Okay? So again, you multiply the dimensions of this cube by 4, and now we have a new cube. What happens to the surface area? In order to find out what happens to the surface area, we first have to find the surface area of the original. So the surface area of the original, since we picked an easy example, all of these sides or all these faces are congruent, and they're all 1 by 1, and there's a front, back, left, right, top, bottom, so there's 6 faces, and all of them are 1 by 1. So it'll be 6 times the area of 1 times 1, which is 1. So the original surface area is 6 units squared. So what happens to the surface area? It's going from 6 to what? So let's find the surface area of this one. It's a cube, so it still has 6 sides, and each side is 4 by 4. So this will be 6 times 4 times 4, which is 16. Do a little bit of scratch work. 36, 6, 7, 8, 9. And the surface area of the new is 96. So the question is, how do these surface areas compare? Well, it went from 6 to 96. So it went surface area from 6 to 96. The scale factor is 16. So what happens? It gets 16 times bigger. That's the idea. That would be the answer to that question. 16 times bigger. What happens to the volume? Well, the original volume is base area times height. So base area is 1 by 1, which is 1, times the height, which is 1. The volume of the original is 1 unit cubed. This is base area, which is 4 by 4, which is 16, times the height, which is 4. And 16 times 4, 24, is 64 units cubed. So how do we go from this to this? How do these compare? How do the volumes compare? It was 1, and now it's 64. So it gets 64 times bigger or larger. Okay. Back it up really quick. How do the dimensions compare? The dimensions were 1, and then they became 4. So the scale factor was 4. Okay. So that's how we're going to do these kinds of problems. We're going to create ourselves an example and actually do the math to see how does it compare? How does it change? It went from 6 to 96. It got 16 times bigger. It went from 1 to 64. It got 64 times bigger. Okay? Now, this is a little bit of a bonus. Look at the units for each measurement. Do you see a pattern? So, when we're talking about the dimensions, it's like 1 unit, right? Surface area is units squared, and volume is units cubed. So we're trying to look, is there a difference between this and this? And this and this. And this and this. Okay? And the pattern is, and you don't have to use this, is that if you know what the one-dimensional change is, right, then you square that, and that's going to be the two-dimensional change. Right? So since we knew that we multiplied the dimensions by 4, right? So that means that 4 is kind of our change in units. The surface areas are going to be 4 squared, so 16 times bigger. And the volume is going to be 4 cubed, which is 64 times bigger. So let's say that instead you multiply the dimensions by 3, right? The surface areas will be 3 squared, which is 9 times bigger. And the volumes will be 3 cubed, which is 27 times bigger. But that is not something that you have to memorize. That's just something that you could if you wanted to. Let's do some examples. We're going to do 2 examples together. Again, I'm going to be creating examples in order to show how to do this. Okay? So, number 1. The side length of 2 similar squares are in a ratio of 1 to 2. So we're talking about side lengths of 2 squares. So let's draw 2 squares, an old and a new. So their side lengths are in a ratio of 1 to 2. So what that means is for every 1 unit on this one's going to have 2 units. That's a ratio of 1 to 2. So 1 to 2. The scale factor here is 2. What is the ratio between the areas of the 2 squares? So let's find the area of the old one. It's 1 times 1, which is 1. Let's find the area of the new one, 2 times 2, which is 4. So the ratio of the areas is 1 to 4. Again, I just created an example and found what they were asking for. Okay. Number 2. The dimensions of a prism are divided by 5. Pause. We're talking about a prism. So I'm going to go ahead and draw a prism. And it said that they are divided by 5. So we actually know that it's getting smaller. From here to here, we're dividing by 5. So let's pick an easy number, right? If I were to pick 1 and divide that by 5, that means that this would be 1/5, right? So let's pick an easier number than that. What number is easily divisible by 5? 5 is easily divisible by 5. We divide all those side lengths by 5 and we get 1. Okay, how do the surface areas change? So we need to find the surface area of the original. We need to find the surface area of the new one and ask ourselves, how do we go from here to here? What's the scale factor? So again, this is a prism, so every face is congruent, and there are 6 of them, and they're all 5 by 5. So 6 times 5 times 5, which is 25, and 6 times 25 is 150. Okay. Surface area of the new one, every face is congruent, and there are 6 of them. So 6 times 1. So the surface area of the new one is 6. So the question is, how do we go from 150 to 6? Okay? If you don't know, you can go to the side and do what is 150 divided by 6. 6 goes into 15 2 times. 6 goes into 30 5 times. So to get from here to here, we're not multiplying by 25, but we are dividing by 25, right? So what happened? We'd say one of two things. Either one, it got 25 times smaller, or we can say that it's 1/25 the original. So when we divide the dimensions by 5, it's going to become 1/25 the surface area. It was 150, now it's 6. Okay? So this stuff is hard. Go back and rewind and watch the video again if you need to. Use the answer keys to help you on the practice.